So hello and welcome back. We are continuing with examples of common factors, and we are now going to be looking at example number 4, 5, and 6, and we are specifically looking at the common factor when it comes to algebraic expressions, right? And when we look at algebraic expressions, you will find that it's quite easy. Factorizing algebraically is much easier than factorizing numerically. So in the examples that we do now, all of these examples may include a number, in other words, numerical factorization, as well as variable factorization, which is algebraic factorization. So I'm going to take the one here, and I'm going to do a squared minus a plus ab. Now, why do I say that it's very easy to see what algebraic factorization is about is because if I look at each of these terms, this is an expression, and this expression contains three terms, right? It contains three terms. Then you ask yourself, what do you see in every one of these terms? Well, I see an a over there, I see an a over there, and I see an a over there. And each of these terms, if we have to factorize it, this term is actually a multiplied by a. This term over here is just a, and this term over here is a multiplied by b. Okay, that's a times a, that's a, and that's a times b. That's negative a, or negative 1 multiplied by a. But again, what do you see in every one of them? What is common? Well, there's an a, there's an a, and there's an a. We don't circle two a's because there isn't two a's in every single one of them. There's only one a in every one of them. And so that gives you a clue already. That tells you that we are going to, as in the previous examples, it tells you that in the above expression, a is a common factor. In the above expression, we can clearly see that a is a common factor. So what I'm going to do next is I'm going to factorize this expression, and we'll see how we do that. That is a squared minus a plus a multiplied by b. Okay, so when I said that a is a common factor, it means that I'm going to pull out a and I'm going to structure it in the same way that I would usually have multiplied out products. Okay, so I take out a because I see a in everything, and then I open a bracket. Let's just give that a moment. I open a bracket, and then I say, okay, we're going to work backwards now. We're going to say a multiplied by what will give me a squared. A multiplied by what will give me a squared? And the answer is it's just a. Then we say, let's just put that in blue. Okay. Then we say a multiplied by what will give me negative a. A times what gives me this middle term? Well, firstly you have to look at it. This here is a positive a. Now positive times what will give me a negative? Very good. A positive multiplied by a negative will give me that negative. And a multiplied by what will just give me a? Well, that's easy. It's a multiplied by 1. Okay. And then finally, a positive times what will give me a positive? Positive times a positive will give me the positive. A times what will give me a? Well, that's just multiplied by 1. And if it's 1, I don't need to put it down if I have other variables as well. Okay, but I'll put it down for now. And then multiplied by b. Okay, and then that gives me my solution. Now to check if the solution is correct, what do? To check it, we take the exact same thing below and we multiply it out and we see if we get the thing above. So I've got a, and I've got a minus 1 plus 1b is just the equivalent of b. And let's multiply that out. Let's say a times that over there, then a times that over there, and then a times that over there, and then let's see what answers do we get. Well, a multiplied by a positive times a positive is just positive, and a times a is just a squared. Then a times minus, or positive times negative, is a negative, and then a multiplied by 1 is just a. And then finally, a positive times a positive is a positive, and a multiplied by b is just a b. Okay, and there we go. That and that is equivalent. So this process above is called factorization. When I end up with something that results in a term multiplied by another term, even if a factor multiplied by another factor, that's called factorization. This process over here is called multiplying out products. Okay, so we can say that factorizing is the inverse or the opposite or the reverse process of multiplying out products. Okay, so that was example number 4.